सेमेस्टर फुल डे है, तो फोर्थ सेमेस्टर में उन्होंने कुछ काम किए, वो पेपर अभी हमारे को दोनों ने फिर अपना अपना, that girl also took up programming as a challenge. Now she is also comfortable with programming, not very kind of a ठंडू टाइप थिंग, लेकिन चलो अपना काम कर ले रही है. उसने भी एक पेपर बना दिया अपने अपने काम करके, अपना सॉफ्टवेयर. तो इनिबिशंस आपकी अपनी माइंड की होती हैं, शन देम. और आपके पास यू आर 25 पर्सन, तो चार तीन तीन लोगों के लिए, दो दो लोगों के लिए ग्रुप बनेंगे तो 12 ग्रुप बनेंगे. और ये करिए कि हर एक बच्चा दो 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 वो करना प्रोजेक्ट. तो अगर ग्रुप में करो तो 4 प्रोजेक्ट हो जाएगा. और अगर चलो 4 ना भी हो तो 2 तो कम से कम हो ही जाएंगे आप. 30 दिन 35 दिन आपके पास है, उसमें बहुत लंबा टाइम होता है. आप अपना मस्ती भी करो, घूमना फिरना वो भी करो, बट डेडिकेट सम 2-3-4 आवर्स फॉर दिस प्रोजेक्ट वर्क टू स्ट्रेंथन योर बैक. बिकॉज अल्टीमेटली यही चीज़ आपको लेके कैंपस की प्लेसमेंट की गारंटी देगी या आउट ऑफ कैंपस प्लेसमेंट की गारंटी देगी. और कुछ आप पढ़ोगे लिखोगे, ये नंबर आपके कहीं मैटर नहीं करेंगे. किसी ने 80% ले लिए, किसी ने 75% कर ले लिया, तो दैट विल नॉट मैटर. चलिए अब आई थिंक यू विल कंटिन्यू विद फ्रॉम वेयर वी हैव लेफ्ट. कल फिर प्रोजेक्ट के बारे में थोड़ी सी बात करेंगे, तो आई आल्सो जाएंगे.
Okay, so let's start. So regression, we cannot apply regression in every.
अच्छा, मैं आई ट्राई कि छोटा सा रिसर्च स्कॉलर्स के साथ एक सेशन आज कुछ हो जाए 1 घंटे का.
Sure.
जो आदमी आपको होता है.
Yeah. Okay, so just for fun, you cannot apply regression in every scenario, right? Wherever you see the continuous value. So what I will do is I will not talk about how to divide the data in test and train. Maybe you already know about it, right? Yeah. So you have this whole data, you divide it into training and test. Somebody said training and test. Right, it's fine. So this is training data, and then you basically create a model on training data, and then you test on for example, here we are using linear regression, but we will talk about different algorithms in some time. What are the other algorithms which you can use? Then you have these model, and basically then you test it on your test data. Okay, so I think so let's suppose there is a new data point. So that the model has already learned. Okay, so the model has already learned, and now the new data point has arrived. We don't know the performance of the student yet, but in the morning before the exam, the student has said so many hours he or she has slept. So we know the number of hours, and we would like to predict what would be the performance of the student after the exam is finished. Okay, and to do that, you know that what we do, basically we do a projection in this best fit line, and we go to the y-axis and we say most probably this would be the value or the performance of this data point would be. Okay, now what we did just now is a simple linear regression. When you have more than one feature, okay, then it becomes multiple linear regression. So instead of like you visually, what you could do is that there is a y-axis, there is a z-axis, there is another axis, and all these different axes are the features, and now you have to create or fit this line in such a way that it fits all these data points. Okay, you know about multiple linear regression, right? Okay, so we will skip this.
So we talked about the gradient descent. We use this function, but not always. It won't be the case always. Like we have this this function. Sometimes we'll have this function, and then it will be a plateau, and then it will even go down further. What will happen? It will find a local minima, but that local minima will not be the best minima. There will be some value even below that, but it will the point it will use that only minima.
Yes, so that's what I was saying. all these machine learning algorithms are kind of approximated. So whatever technique you are doing, you are the best fit line. You cannot say this is the best. Sometimes the local minima that gradient descent is trying to find, it might get stuck at some point, and then the best so-called best fit line might not be the best fit line. It can happen. Okay. So let me talk about. Do you know what is collinearity? Anyone has heard of collinearity? Okay, good. I can talk about it. So, pink things are dependent variable or the value that you would like to predict, and the greens are the independent variables or the features that you are predicting. Slowly we are moving towards collinearity. Okay. So let's think about a scenario. I don't think there are Zomato things here.
No, sir.
No.
It is working. Swiggy and Zomato works.
Swiggy.
Both,
Okay.
both Swiggy and Zomato are working.
Okay. Well, I mean, I thought because it's very terrain steep, so people might not be doing that.
It delivers, not in summer,
But
where
in
my
only
place is.
around trades or in New Shimla.
Okay. So let's but you know what is a Zomato, right? So you deliver and then this guy will come and okay. So what happens, think like this scenario where a person has got orders and he has multiple orders to deliver. Okay. So the number of deliveries or the number of orders, here I am taking deliveries, but you can also think about number of orders also. And what is the total distance this person has to travel to deliver these number of orders. Okay. Now, and delivery time is the predictive variable. So there are two things. Estimate the delivery time. This delivery time is the predictive variable based on total distance of the trip and the number of deliveries. Is it clear? Problem? Okay. But total distance and the number of deliveries in this case are kind of related with each other, right? If my number of deliveries increases, it means most probably my distance will also increase. Is it okay? This concept is okay? So what do we see? That distance and the number of deliveries, they are somehow related with each other. Okay? And if we try to put all the features to our model, thinking that this model will help us in a better prediction, it's not always the case. Especially in this case, the problem of collinearity is occurring because the distance and the number of deliveries are correlated. So whenever you are trying to create a model, what is the difference between a model and the algorithm?
An algorithm.
नहीं रुक जाओ, somebody else out. What is the difference between a model and an algorithm? You can look at me, I'm not that bad. So, what is the difference between a model and an algorithm? Anybody knows? Kuch idea? Okay. I know you know everything, it's just I have to use this pen so I start asking questions. So, you know this linear regression, right? Linear regression, logistic regression, random forest. Okay, these are all algorithms. These are all algorithms. Okay. Now let's suppose I will say my model consists of two features, that is distance, comma, number of deliveries, and I am going to use, let's say, linear regression. I'm going to use linear regression to predict the time using these two variables. Let's call it model number 1. Another time I am only going to use the number of deliveries using the linear regression. It's called model number 2. So these two models are different. Now you got it? The difference between a model and an algorithm? Let's take another scenario, model 3. I will use distance comma number of deliveries, two input features, and this time I'm going to use random forest. This model is different from model 1 because the algorithm is different. So these two models are also different. Is it clear? Okay, very good. So, clean and close. So, you have to be very careful when you have, let's say, 10 input features. What you should ideally do is create a correlation matrix. You know what's a correlation matrix is? Yes or no? If you don't know anything, please speak out.
Sir, can you please explain?
What is a correlation matrix?
Sir,
This is my question. पता है?
explain करने आपको.
और यही तो question है. Explain में क्या करूँ?
Sir, answer नहीं पता.
So, what is a correlation matrix? अच्छा वो तो किया ही नहीं है. I'm not still an expert. So, correlation matrix is nothing but. इसको close करूँ?
Sir.
नहीं. अच्छा got it. I know, I remember. Okay. So correlation matrix is nothing but, I know you guys know. So let's suppose there are 4 features. Feature 1, age, income, वो तो एक ही बात है, zip code and so on. Okay. And here also you have the same features. F1, F2, F3, F4. You do a correlation of these two features, you get a value. And you enter those values in these boxes. This is a correlation matrix. You can represent it using heat map also. Pata tha na? Okay. So it is very important that first you draw this correlation matrix. Okay? Because then your objective should be, let's not use the variables or we call them features which are highly correlated. यहाँ पे देखा कि ये feature 3 और feature 2 की value 0.9 है, 4 और 2 की भी value 0.87 है, ठीक है? लेकिन 3 और 4 की, ये है 3 और ये है 4, so 3 और 4 की value 0.2 है. So what you should do? Use only these two variables, F3 and F4. क्योंकि F2 अगर use कर लोगे तो क्या होगा? Sorry, F2, which is very highly correlated with ये collinearity problem आ जाएगी. So and what happens when the collinearity problem comes? It affects the performance of your model. Instead of having a better prediction, it starts giving you a bad prediction. Have you heard of overfitting? This can lead to overfitting. Okay, so you should avoid collinearity. And how can you find it? Correlations, scatter plots, and so on. So there are multiple ways to evaluate your models. Now we will quickly talk about different metrics and then let's jump to the classification. You know these different metrics, right? MAE, mean absolute error. Okay, so my slides are not moving. Okay. So mean absolute error is what? Basically you take the difference, and let me go to this mean square error. Mean square error is clear, right? Because this is what we did, sum of square error, right? And if you take a mean of it, then it becomes mean स्क्वायर एरर का मीन कर दिया, एवरेज कर दिया, दैट्स मीन स्क्वायर एरर. अब इस मीन स्क्वायर एरर का अगर रूट स्क्वायर कर दोगे तो रूट मीन स्क्वायर एरर हो जाएगा. ओके. Similarly, why we are doing this square? Because negate हो जाएगा अगर if we don't do that, some will be positive and negative. Similarly, there is another way to handle these negative values using absolute function, right? You know this absolute function. So there is again, we do an absolute, इधर की line हट गई है वैसे, so you do an absolute of this, so you get only positive values. You do a sum of it, you get absolute error. You do a mean of it, n number of values, so you get a mean absolute error. Is it clear? That's how you get mean absolute error. So now we have different errors. ऐसा क्या होता है कि एक में एक error क्या पकड़ता है and what that other error cannot find it out. Have you thought about it? What can mean absolute error does can catch which root mean square error or mean square error cannot do, but mean square error can do something but mean absolute error cannot do. Have you thought about it? Okay. Again, I found it from these technical blogs. I think I told you to. How many of you have subscribed to this? So I see 2 hands, 3 hands. You said yesterday also.
Already subscribed.
You had already subscribed. So at least I see 3 hands coming up, which is very good. In a class of 25, 3 people have subscribed yesterday. What is my performance? 3 divided by 25 multiply into 100. कितनी होगी? ज़्यादा अच्छी नहीं है ना? So if you have to predict the performance of Rajesh Sharma, the value of y is very, very low. Anyways, now think about it that suppose there are you are predicting the errors, okay, predicting values. Now when you are predicting the values, some of the values, let's suppose there are 10 data points. 10 data points we have to predict the values. लेकिन 9 के हमने predict किए बहुत अच्छे थे, बहुत कम error आया. लेकिन जो 10th था उसका हमने इतना गंदा prediction किया कि उसका error इतना बड़ा था कि that when we do a square of that and then we do a mean after that, it's still very big. Because square कर दिया हमने. अगर error 4 था, square करने पे कितना हो जाएगा? 16, 16. And then even if we do a mean with other values after adding other values, it still be a very large number. Now take this scenario. Instead of doing the error square, what we do an absolute. Absolute में इतना फर्क नहीं आएगा. So what can mean square error catch? अगर कुछ data points के error बहुत ज़्यादा हैं, सिर्फ कुछ ही data points के, बस बाकी के हमने बहुत अच्छे कर लिए, तो mean square error वो पकड़ लेगा, but mean absolute error वो नहीं पकड़ पाएगा. ठीक है? So you can check these blogs. I think everything is getting recorded, right? Okay. So go for it. Try to find what something can catch, some other cannot catch. Okay? Okay. Wait. We can skip this. So sometimes technically some people say there is a loss function. Have you heard of this term, loss function? So ये जो errors, what we did, sum of square error, उसका फिर square root, these are all different kinds of loss function or loss function or cost function. Sometimes if in an interview somebody asks loss function बताओ, हमने तो पढ़ा ही नहीं, तुमने पढ़ा है, but this is what you call it. There are different kinds of loss functions, and these are just few. Okay. Now in this slide, what you see is that you have these errors here, okay, and each are different kind of scenarios, right? So what do you see? The MA, so you see that यहाँ पे एक में error 20 है. Please pay attention. अगर if you need a break, just let me know. Otherwise, I will finish this, then we take a break, and then we will, after a break, we will start classification. Can you accommodate? Okay, just stay with me for another 10 minutes. ऐसे ही बच्चों को lollipop दे दे के we extend it. Anyways, so what you see is different scenarios. So I was telling you this scenario where there is error 20, ठीक है? और यहाँ पे इसी की वजह से error हो गया 400 इसमें. बाद में edit कर लेना my jokes. What should I do? Should I stop?
Less than 2 minutes, sir. Just
क्या हो गया? My joke was too bad. So we have to take a break. Manu sir has logged it from outside. Okay.